here.
All right.
All right, so it says, I believe, please double check this is the right problem. Find the area of the rhombuses with the following dimensions: a base of 9 and a height of 7.
Yes.
Okay, so it's sometimes a good idea to actually draw it. You don't have to be that accurate. A rhombus is like a square that's pushed over. So the base is 9, the height is 7. Couldn't be a more basic question here. The area is always base times height, which is 9 times 7, 63.
Yeah. Okay. That's pretty straightforward.
With the diagonals, there's where you got a little bit more to consider here. Again, not to scale. Do you remember anything about how the diagonals intersect in a rhombus?
I want to say they bisect each other.
They do, and they're a right triangle.
Mhm.
So if this one kind of going top left, bottom right is 6, that's 3 and 3, and then this is 5.5 there. So how do you find the area? Well, you could use some triangle stuff here to find it. You can also use the diagonals, though. I believe there's a formula here. It's 1/2 diagonal 1 times diagonal 2.
Mhm.
You remember that?
Yes.
Possibly. So you got to be careful here to not go off and wander in different directions that are unnecessary, because they're giving you everything that you need in this problem. This is also something you might see on standardized test prep stuff that I do as well, where there is a shortcut if you know what to look for.
Okay. Perfect.
All right, question 3.
Okay.
All right. Yeah. All right, find the area of each shaded region. So a lot of times I think it's worth actually making 2 drawings here. These are called composite shapes, and then as best you can labeling or relabeling them, and then getting the new dimensions, because we know it's the big one minus the little one. And the little one here, hopefully you see that the 7, you take away the 2's, so that's 3. The 13, you take away the 2 3's, which is 7. 7 times 13 minus 7 times 3. Are you generally allowed to use a calculator on your exams?
Yes.
Okay, so feel free to jump in, do those calculations, or let me know if you have any questions on that.
Okay.
All right, so if you were given a question like B on your exam, you would want to rotate your paper, not your head. You don't want to put a crook in your neck. You want to rotate that until you realize, like, what is the base? The base is usually the thing that it's sitting on. Now, you might also recognize what this is, but at least if you were to rotate it, you would see that there are 2 parallel sides here, or 1 pair of parallel sides, and this is actually the height, this 4 here. But you might want to rotate it. Sorry, I didn't rotate that correctly. You might want to rotate it so that you can see that what it's sitting on, the 7. This is hard to do. If I had the paper here, you do it. There we go, that way, and like that. So this is the 4, this is the 7, this is the 5, and now maybe it looks more like what you're used to. This is a trapezoid.
Mhm.
Do you get a reference sheet going into your test?
Nope.
No. So it's all short-term memory.
Yep.
You probably talked about that with unit circle.
That was
All right.
really bizarre to me. I was like, how come I don't get a reference sheet?
Yeah. But I only asked because I would tell you this might be a formula to write down. The area of a trapezoid is 1/2 base 1 plus base 2. And sometimes there's confusion about which is base 1 and base 2. The bases have to be parallel. So this is a base and this is a base in this problem. You can't go by eyeballing it and what you feel. It's what is parallel times the height. So 1/2 7 plus 5 times 4. Looks like it might be 24 there. Okay, so C is a problem from the other night. we talked about there is a formula for it. If you don't know the formula, you have to drop an altitude, make a right triangle. Remember that this is 60 degrees, 30 degrees, and use that to find the long leg, which is the height or the altitude, which ends up being, this is 4 half the hypotenuse, 4 square root 3. So
Mhm.
you can use 1/2 base times height, or for just equilateral triangles, it's the square root of 3 over 4 times the side squared.
Okay.
You have to decide which one you like. They give you the same answer. Is it worth committing that to memory? I don't know. Can't answer that. But maybe your teacher said you cannot use this formula, and then in that
No,
case,
she gave us all of the formulas that we can use for each one. So
yes, the rules of engagement.
yes.
You have to know the rules. All right. Number 5. And always check me here. Sometimes I do go off and snip the wrong one, but I believe this one is next.
Yes.
All right, find the area of the parallelogram. So the area of the parallelogram, same as a square, same as a rhombus, same as a rectangle, it's base times height. So if you knew the height, you would be done because you already have the base. How can you find the height from this information here?
Well, she talked about using like right triangle trigger to like find stuff. And if you did that, then it would become a 30, 60, 90, I believe.
Yes.
So
So are they giving you the short leg, long leg, or hypotenuse in this triangle?
they're giving us the hypotenuse.
Good. And sometimes it's a good idea to kind of draw it off to the side so that you're not distracted by all the other stuff going on here. You don't need the short leg, you need the long leg, but sometimes you have to give the short leg to get the long leg.
Mhm.
What would the short leg be in this case?
So the short leg would be, if we're using that like trick thing, it would be um the X part, and but it
Yes.
would be 4.
Yes. So this thing I've drawn on the left here, this is way more important than any of the other formulas. Like, you are going to get problem after problem like this, in my opinion, where you're going to have to use this.
Okay.
This is really emphasized in your course. So just, keep that in mind. 4 square root 3, that's the height. So the area is base 12 times height, 4 square root 3.
Okay. Cool.
15. We're making good progress, but just, maybe the next one has, the next one has a bunch of,
I know it's like you have like a bunch of like short ones, and it's like ha 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 A B C
yeah,
D E F G.
yeah. All right, find the
It's really a whole
ratio,
lot of book.
yeah, of the areas of figures. Okay, why are they giving it to you like this? Okay, I guess you just find the areas. There is another way to do this where you find side length relationships and then use a scaling factor, but it doesn't sound like that is what's being asked for here. You literally just have to find the area of each. So triangle on the left, 1/2 base times height,
Mhm.
15 over 2, 1/2 base times height. So
That
on the
would
right.
be 12, I believe.
Now, what is not stated is whether you go from the one on the left to the one on the right. I guess they're using this colon to do it that way. So you generally don't leave fractions in your ratios, and you can
Mhm.
kind of treat them like fractions where you can multiply the both sides by a scale factor or a number here 2, for example, and
Okay.
that will give you 15 to 24. But then you're really not supposed to leave it when you can reduce both of these by the same number. They're both divisible by 3.
Mhm.
I don't really know how to
So they
show
want
that.
5 to 8 then.
Yes, exactly.
Okay. Yeah, I think that's how she wants us to do it. So
Yeah, now just as an aside here, I am just shocked that you weren't asked to do like 13 and 14. Like those seem like test questions to me that you would be asked, but maybe you covered those in a previous.
13 and 14, you said?
Yeah, am I in the right place? Yes, okay, just making sure.
I'm gonna make sure too, because if those are like things that you think would be on the test, she's like weird.
Well,
So
they're not triangle-y, but they're circle stuff. I don't know if you guys are doing
yeah, we
circles.
have been, yeah.
Yeah, I mean, if we got time, we can go back. We do need to talk about B. Um,
Okay.
so here we go for part B, letter B here. So there's this thing where if you have lengths from one to lengths of another, and this
Mhm.
does include perimeter, not just side lengths, there's typically a scale factor that affects that, like to go from one length to the other. Like in this case, to go from 18 to 24, you end up multiplying by 4/3. Okay, just take my word for that for the moment. For areas to areas, and we're talking about similarity here, you take that k and you square it.
Okay. So
So here's how that works in this problem here. It's 18 to 24 in this problem. Think of it as a colon here. And if we reduce that, that would be divided by 6 on each. That's 3 to 4. Is that okay?
I think so. So for
But that's the lengths, not the area. We're going to get to that.
okay, so for the lengths, it starts with like 18. Where did we get the 6 from again?
I'm just picking the thing that divides both 18 and 24 evenly.
Oh, okay, okay, okay.
But you got to make sure the mapping, like if one was rotated or something, you got to make sure you're getting the right sides here.
Okay, so then it would be 3, 3, 4.
3 to 4 for the lengths, but you're asked about area. So area, you have to square both of these, and we can talk about why maybe at another time, but that is the like thing to remember that might not have been clear.
I think we talked about that in class, so yeah, I'll remember that. So the area would be the length ratios squared.
Exactly.
Okay.
All right, 16. Find the coordinates of B so that triangle ABCD, sorry, ABD, can't read that one, that one there, ABD will have the same area as triangle ACD. Okay. All right, so what we can't assume is the symmetry. Like we can't assume that B is at -6. We can only assume that it's some value, and I'll call it -x comma 0 for the moment, which means that this distance is x and this distance is 6, and the base of this triangle is x plus 6.
Okay.
If you don't like x, you can switch the letter, but like structurally for this problem, do you see that even though the coordinate's -x, the length is x away from the origin?
Yes, I see.
So this triangle, and you'll see me just over and over again where I kind of grab a piece of it and just pull it off to the side. Its base is x plus 6. What is its height?
Its height would be 9.
It is 9. So we can find the area of this triangle. It's 1/2 x plus 6 times 9. All right, so we're going to leave that off to the side.
Okay.
Here's the other triangle. It too has a base, which we can calculate, and it too has a height. The base you can calculate as right minus left. the right value minus the left value, 14 minus 6. And what
Okay.
is it? And what is its height?
Okay. And its height is also 9.
Height is also 9. So the thing that you will learn the more math you take is sometimes you don't actually simplify. You just write out the stuff because you might get some cancellations later. And since you're in an honors class, they kind of think you're going to think that way.
Mhm.
And I'm going to show you that here that it was wise to wait to simplify. Do you see how there is a 1/2 on both sides of the equation?
Yeah, so that can just go.
9 on both sides of the equation. And that really reduces the complexity of the equation you're solving.
Yes, so if I'm gonna do that, I should just wait at the end.
Yeah, typically that's better in your course. Another
No.
class, maybe not.
Okay.
Um, so X is 2, but we got to be careful here. Is that what they wanted? Did they want you to find the value of X? When you go back to the prompt here, does it say, what is the value of X? No, it
No.
says the coordinates. So you have to be very careful that you actually give the coordinate, not
So you find the coordinate of B so that it would have the same area, so X would have to be -2.
well, X is 2, but the coordinate is -2.
Yeah.
And, minor little thing, but you don't want to get dinged on something like that when you're submitting your test.
Okay.
All right. 17. All right, moving to problems without pictures, which means you have to draw the pictures. All right. Find the area of a triangle with sides 41, 41, and 18. This sounds like Hero's formula or Heron's formula. Can't
Oh,
remember.
I keep forgetting this one. This is where I always mess up.
All right. This is actually one of the few I don't know off the top of my head. I know it involves the half perimeter.
Yeah, it's like the side one or whatever thing.
All right, images. There it is. I just went by it. Okay, so the first thing you have to find is what's called the half perimeter. The half perimeter is adding up all the sides. And they're generally in increasing order. So it's A plus B plus C divided by 2. 18 plus 41 plus 41 divided by 2. So that is nice. That's as nice as you can get there. That's 50. And then the area, I don't know how to tell you to remember this, but it's the half perimeter. They call it semi-perimeter. I like half perimeter in some books. S minus A, S minus B, S minus C. Since you're subtracting, your semi-perimeter better be bigger than all of the lengths.
Okay.
So 50 minus 41, 50 minus 41, 50 minus 18. All right.
I'll
I
just
know
put
you get,
this into my calculator.
okay. Yeah, I was going to show you that you can do this by hand because a couple of these are nice. 32 times 50 is 1600. So I know you want to do it with the calculator. This is the square root of 1600 times the square root of 9 times the square root of 9. 40 times 3 times 3. If you're going to do it in your calculator, do it twice. Make sure that you are for sure,
Okay.
got it. There could be units. We're not seeing a lot of units in this test or this practice test. Does your teacher typically emphasize units?
Yes, we get points taken off if we don't do them.
So we've done no problems have we done tonight that have had units. So just maybe at the top.
I've just been putting units squared so that I know.
Oh, good. That's really good because I'm doing nothing. I'm getting dinged on every problem here from your teacher. So, all right, 24.
Okay, hold on. I'm just writing down the answer to the last one.
Sorry, let me get.
You're good. Okay. All right, what was the next one was?
I believe it's 24 here.
Yes, 24.
All right. We did a bunch of these the other day, right? There's
Mhm.
something really special about a regular hexagon. This one's kind of drawn awkwardly, but I'll remind you that the hexagon has 6 equilateral triangles inside of it. And equilateral triangles are the nice ones. They're the 60 degrees. You can cut them down to the 30, 60, 90s. Okay. So there's a couple of ways to do the area of a regular polygon. So one formula you need to remember is 1/2 the apothem times the perimeter.
Okay. A equals 1/2 apothem times perimeter.
And these are kind of case specific. So it's like if they give you enough information where you can do this, you might consider using it. I sometimes think it's better to find the area of a triangle and multiply that by 6. Like if you're really stuck, any of these are good. So what they're trying to show you here is that the distance kind of across is 36. So half the distance is 18. In your drawing, that corresponds to something like that. That's 18.
So would that be the apothem?
It is. It is, yes. So it might be wise to draw like a single triangle with the apothem 18 and the 60 degrees here. I'll draw in the reference triangle.
Okay, so 18 equals x root 3.
Good. You got to solve for x, please.
Okay. Okay, x equals 6 root 3, I believe.
Okay. So the entire side would be 12 root 3.
Mhm.
Okay, so again, you have a choice here. You can use the 1/2 the apothem times the perimeter, which works really good here. You've got the apothem. You can calculate the perimeter. There's 6 of those, or you can find the area of one of these triangles and multiply by 6.
Mhm. Okay, so we're finding, so the perimeter would be just 12 root 3 times 6.
Yes.
So that would just be 72 root 3.
For the perimeter, yes.
Yeah, for the perimeter. Okay. So area equals 1/2 18 times 72 root 3, which is 648 root 3.
I'm gonna take your word for it at this point. The apothem is 9. Yeah, that sounds right. 9 times 72. 10 times 72. Wait,
The apothem is 18.
yeah, but half of it's 9. So sorry. So 10 times 72 less 72, 720 less 72 is whatever, 48. 652. Is that what you said?
I said 648.
648. That sounds right.
Okay.
Got my 2s and 8s. Okay.
Okay. And then 27.
All right. Give me just a moment here. The next one, 27. Okay. So yeah, that's what I was kind of referring to when I said, hey, why aren't we doing like I think it was 13 and 14? Find the area of the shaded region. All right. So what I see here is I see the pizza slice, subtract the triangle. The pizza slice being the quarter circle.
Okay.
Is that something you feel like you're good at visualizing?
Yeah, she also gave us like equations for like the area of a segment of a circle as well.
That's very specific.
Yeah.
And I'm not in. I mean,
I think I might have it. I mean,
One of the really interesting things about how the brain works is it's better to find pathways that lead to something rather than to know this. That's a lot harder than leading.
yeah, it says that the area of a segment of a circle is 1/2 AB times sine. Where it is.
The crust. We're
Yeah,
finding the crust here.
yeah,
AB sine. You got to be careful with that. That is not the right formula to use for
yeah, for this one.
right triangles. It works really well for non-right triangles. Have you guys done law of sines, law of cosines?
Yes.
Okay, so there's really, you've seen me do this before. If you're going down the right triangle, you don't want to use any of the non-right triangle stuff.
Okay.
And there's formulas for area, there's formulas for perimeter that have nothing to do with right triangles. And if you mix them, you're going to make it more work for yourself
Okay.
unnecessarily. So land of right triangles, we're going to stick to like a squared, b squared, c squared, stuff like that. So the area of the quarter circle, you start with the area of like, well, what is a full circle? Well, it's pi r squared, but we're not going all the way around. We're going some angle out of 360. In fact, we're going 90 degrees out of 360, hence the quarter circle.
Okay. So then
What is the radius in this problem?
6.
6. So it's a quarter pi 6 squared, like that. Sometimes it's good to label the sides again of the triangle. So we got 1/2 base times height. Which is 18. So as much as you might not like that answer, that is the exact answer.
Okay. That's just 9 pi minus 18.
Yes.
All right.
All right, B is somewhat similar. It's another slice of pizza. Oh, did you know that the Pac-Man was created over pizza?
Really?
Yeah, they were sitting around. True story. They took a slice of pizza out at the table in Japan, of all places, right? They do have pizza in Japan, and that's. I'm not. This is total. I mean, I watched some documentary. I believe it. I mean, it's like, how could this not be
That's
true, right?
funny.
Yeah. So you can take that a little bit to class and see if that gets some extra points. This one's same deal. You're trying to find the area of the pizza slice, subtract the area of the triangle. This one is more difficult because it's not a right triangle. It's an isosceles triangle, but when you throw the 60 in here, and you know that the sides are the same, that means the base angles are the same. The only way the base angles can be the same here, if this is 60, is if the base angles are also 60.
So does that make it equilateral as well?
Yes, exactly. And we've done this a bunch of times. You may want to rotate it a little bit to kind of get it to where it's dropping that altitude straight down. But you have to find the X and the H.
Okay, so we have, so X would be 3.
Yes.
And then H would be 3√3.
Yes. So the area of this triangle is 1/2 base times height. What is the base?
Okay.
What is the base here, this triangle?
The base would be 6.
Yes, and it happens to be the other side lengths. Sometimes that gets lost when you're doing stress of exams. Height is 3 square root 3. So you got that. The other one is just like we were doing in the last problem. It's pi r squared, but we don't want the whole circle. We just want a slice of it. Rather than trying to figure out how many slices go in, you use the angle. What is the angle in here of this?
60 degrees.
60 degrees. So it ends up being 1/6. 60 over 360 pi 6 squared.
Okay, so that's just 6 pi.
6 times 6 is 36, divided by 6 is 6 pi. Good catch on that. And then on the right here, half of 6 is 3. 3 times 3 is 9. 9 square root of 3.
Okay.
Okay,
I got it.
So I'm not sure how you want to remember this formula. The book gives you this one, like 1/2 theta r squared or something. It's in radians, I believe. It's really complicated. I don't recommend that. This one's not usually given. It's not usually given in this format, but I think it's more intuitive for students.
Okay, and I use that formula when I'm
Pizza
trying
slice.
to find the area of the slice.
Yes.
Okay.
39. All right. AT is tangent to circle P at T. What does that mean about PT?
If it's a tangent.
If anything, I guess I'll take any information. I didn't really
Oh,
think
it's
about
like,
making that
I'm
worse.
pretty sure PT is a radius. But
Okay. And then
also
what about the angle ATP? What is that?
that would be a right angle.
Yes. Yes. Okay. So I think you can sort of see the direction we're going here on this one, which is to find the area, you need the base. I'm sorry. I'm doing this awful. You need the big triangle and subtract the pizza slice.
Okay.
So a couple things we got to do here. AB is 12, which means the other one is 12. So that tells you that, wow, that's drawn really bad. This is also 12, and this is also 12. You also know that this is 24. And you can find B, which we haven't done tonight, using a number of ways. Pythagorean theorem works, but you should notice something about these two sides.
Is it one of those relationships? Or that one is.
Let me go back and show you.
That one's twice that.
Yes. So this is the X side. So B is the
X root 3 side, right?
Yes, exactly. So 12 root 3. So area of the triangle is 1/2 base 12 root 3 times 12. And the height, or we got the height there. To find, oh, well, I guess we've got the angle now. What is this angle for TPA?
That would be 60 degrees.
Yes. Okay, so find the area of that slice for us.
So that would be 60 over 360 times pi 12 squared, yes?
Pi 12 squared, yes.
Okay.
Good.
Okay, so 144 divided by 6, so that's 20, so that's 24 pi.
Okay. And then what about on the left there?
Okay, I'll put, that would just be 144 divided by 2, just 72 root 3.
Yes. You got it.
And is that just the answer?
That's it. Yeah. Coming up with the composite shapes is really the important one to recognize that it's the big one, subtract the whatever it is.
Okay.
All right. Are we doing oh, of course we're doing 41. All right. Find the area of the shaded region. So this is the, wow, that's not drawn well. Semicircle minus the circle, which has radius 3. And then I do think it's worth kind of like recognize that you can combining these two to making a full circle.
Okay.
Now we just have to do a little bit of figuring out here, well, what have we got? But we should be able to answer some of that. All right. Okay, so we got 3, 3, 3, 3. We have some other radius here, which is also the same as this here. I feel like this is not. Okay, so this is X. That's X. There we go. Now we're gonna make some progress here. That's X. That's 3. What's this one here? We're trying to find some triangle that kind of works here. I'm struggling here a little bit. So this one, that's 3, that's 3. Is there something about this that we know? That's X, X plus 3. Not seeing it. Okay. Do you happen to have the answer to know how to work backwards from this?
Let me look at the key really quick.
Okay. A hint would help here. So that's that. One, no, 2, 3, X is 3, 4,
Okay.
7.
So for some reason, the review only goes up to number 39.
Of course.
The key.
Okay, so just to do a little bit of me wanting to not do this problem, and also I think to help you more on your test, why don't we go back and look at like 13 or 14 or some other problems that are more likely to be on there? Unless you really
Okay.
feel strongly that something like this would be on there, then I'll dig into a list a little deeper.
Okay.
So
I think she's gonna answer questions before the test tomorrow also, so I can also ask her.
There you go. There you go. I like it. Here is 13B. This is a good question. And then I'll make up one like it that I think I've seen in your class before. So think of this as concentric circles. How are you going to work that out?
Okay, so it would be the big circles area minus the small circles area.
Yes.
And if the diameter is 6, then the big circle's diameter would be 10.
Okay, but do you want the big circle's diameter, or do you want something different?
Probably want the radius. So that would be 5.
Okay. And you can use uppercase, lowercase if you think that's helpful to differentiate it. Some students will use like R1, R2, D1, D2.
Okay. And then do we want it of the small circle as well?
Yes, because you're going to take the large one and subtract the small one.
Okay. So the small one, the diameter is 6, and then the radius would be 3.
Okay, and let's do some real units. Let's say this is in centimeters and centimeters this time. I'm going to just step away for 30 seconds for this. I'll be right back.
Okay.
All right. You have the do you have an answer for me on this one?
Okay, so this one, 25 pi minus 9 pi, which is
Good.
16 pi
What are the units of this one?
centimeters.
Squared?
Yes.
Okay. All right, so here's kind of your classic problem that I think I see in your class a couple of times. Okay, so they want you to find the area of I think like 2 of the 3 rings combined together.
Okay.
And they tell you, I got to kind of do this off to the side again. I shouldn't have done that. Sorry, can do this better. All right, let me copy this. They tell you that it's got a radius of 1. This is 2, and this is 1, and this is 1. They'll do something like that. And you're finding the area of the, let me use the highlighter. You're finding the 2 of the 3 rings. Is that kind of clear what I'm?
Yes.
Okay. So it's kind of jumbled up, but you can do this. This is a doable problem. You just have to kind of separate what circles you're using for each one.
Okay. Okay, yeah, that makes sense. So I just take each one and like add it to each diameter or each radius, like the
Yeah.
radius of that.
So just be careful. The inner one is a radius of 1. The next circle out has a radius of 3.
And then the next circle out have a radius of 4.
Right. And
Okay.
then so on.
So okay. So the radius, so the area of the outside semicircle, the outside circle would be 5.
Okay.
So that'll be 25 pi. And then the one at the inner of that inner circle would be the radius would be 3, so minus 9 pi also.
So just keep in mind, to find the green though, you're taking the biggest circle and subtracting the next circle to find that.
Oh, okay.
Okay. And then you're adding to that the second biggest circle, subtracting the littlest circle.
Oh, okay. So then it would be 25 pi minus 4. So then it would be 16 pi.
Good.
And then that would give you that one. And then you have to do 9 pi minus 1 pi. And so it would just be 25 minus 16, which is 9 pi, which would be plus 8 pi, which would be 17 pi.
Very good. Okay, last thought here is 45, 45, 90 triangles. x root 2. So if I give you that this is 16, what is the x value?
Okay. So 16 equals x root 2. So the x value would be 8 root 2.
Very good. Okay. So don't forget that one. That's another important one to remember. And I think that will probably do it for us for tonight.
Okay.
If all of this made sense, you know, you're in good shape. You're really like going to be okay on the test, hopefully better than the last one.